whatever day it was that we were just last in class. We did graphing method and we did substitution method. Okay, this is going to be elimination. So there's 3 of them, and we're going to actually use the elimination method to solve some more difficult problems as well after this. Okay, so I want everybody to close their computers while we do the notes real quick. Okay, so the first example is already written out for you, but we're going to walk through it and talk about it and then go over a couple of other examples as well. So it says a stack of 20 coins contains only nickels and quarters and has a total value of $4. How many of each coin are in the stack? So N is going to be the number of nickels, and Q is going to be the number of quarters. So it says you have a total of 20 coins. So if I take my nickels and add my quarters, I'm going to get a total of 20 coins. And then it has a value of $4. So how much is a nickel? So 0.05 N plus 25 cents for a quarter equals $4. Now, if I don't want to mess with decimals, how can I get rid of the decimals? Move the decimal. Okay, so if we move the decimal 2 places, we're going to get 5N plus 25Q equals 400. Okay, so what our goal on the elimination method is to manipulate one or both of the equations to where when we add the 2 equations together, one of the variables cancels and drops out. Okay, so we're going to end up multiplying one of the equations or both of the equations by some number that's going to change the coefficients to where when we add them together, something cancels. So for this particular problem, since we have N plus Q equals 20, neither one of those have a coefficient. So it's really easy to make those coefficients whatever we want. So what do y'all want to drop out? Which variable? Doesn't matter which one we take. N. Okay. So if I have 5N on the bottom, so we have this 5N on the bottom, what would the top need to be to where when we added them together, they canceled? Negative 5N. Okay. And so right now it's a 1N on the top. So if we multiply the whole thing by negative 5, we're going to get that negative 5N that we're looking for. So it would be negative 5N minus 5Q equals negative 100. Okay, and then we're going to add the 2 equations together. So what happens when I do 5N minus 5N? Okay, so these are going to cancel. What is 25Q minus 5Q? And then 400 minus 100. 300. Okay, then we divide by 20. What's 300 divided by 20? 15? 15 what? What does that mean? Quarters, right? Okay, 15 quarters. So we're talking about how many quarters and nickels it would take to make my 2 equations equal each other. All right, so then once I have Q and I have another variable that I need to figure out. How could we figure out n? Okay, we could do that. Plug in 15 to one of the original equations. That's going to be the easier way to do it. So if we have n plus q equals 20, and I know that q is 15, I subtract 15 from each side, and I get n equals 5. So the solution is going to be 5/15. 5 nickels and 15 quarters. Now, let's say we had decided to go the other route. So let's say that we had decided we wanted to do the q's. What would I have to multiply that top one by? Negative 25. Okay, so negative 25. And I would get negative 25n minus 25q equals negative 5. So these will cancel. We end up with negative 20n equals negative 100. Then we'll divide by negative 20. What is negative 100 divided by negative 20? Okay, so we end up with the same n value, either way that we do it. So the two people in here could be doing the same problem, multiply by different things, take a different route, get the same answer. Okay, just depends on kind of what route you take. Flip your paper over. Okay, so we're looking at this problem, and you can just write it at the bottom in that blank space. So my goal is to figure out or get to a point where when I add the two equations together, a variable cancels. So what do I need to multiply by? Exactly. Okay, in this particular case, I don't really have to multiply by anything because the y's are already opposites of each other. Okay, and so when I add these together, my y's are already going to drop out. Okay, I wanted to point that out because sometimes we'll get so caught up in, oh, I have to multiply by something, and we'll miss out on the easy ones trying to do extra work. Okay, so we're going to combine and get negative 7x equals 5 minus 40, negative 35. And we get x equals 5. So then we'll plug that in. We get negative 10 minus 3y equals 5. Add 10 to both sides. So y should be what? Negative 5. So we have the point 5, negative 5 as our solution. Okay, I want to do one more, but I don't want to do the whole problem. I just want to set it up, like figuring out what we're going to multiply by. Okay, so let's say this was our problem. Is there any one number that we could multiply by that's going to get us to where we need to go? So this is the situation where we're not just going to multiply one of the equations by something, we're going to have to multiply both of them by something. So which variable do y'all want to do? X? Okay, so what is the easiest number to turn 2 and 5 into? 10, right? So most of the time, if you just multiply the two numbers together, that's probably the easiest thing to do. So what would I need to multiply this top one by? Okay, we could do 5. What would I need to do down here? Negative 2. Okay, because I need one of the two equations to be positive in the front. Okay, so then we could do negative 10x minus 15y equals 25. 10x plus 4y equals negative 28. And then we could go from there.